Hello students, welcome you to this session. So we are studying how to find adjoint, right? So last class we studied that. And in today's class we are going to study another thing that is called inverse of a matrix. How to find inverse of a matrix, that's a very simple thing. But the basic thing what you need is how to find cofactor. Hope you would have practiced a lot of questions. 2 by 2 is easy, right? But 3 by 3 will take some time. So you have to find the cofactor of every element, then cofactor matrix, then you take transpose, that is called adjoint of the matrix. Okay. So in today's class is just continuation of that only. So today's class and even the next class. So what you need is how to find cofactor. Those who are not practiced, you practice well, then this will be very easy for you. Okay. So now first let me explain what is inverse of a matrix. Inverse of a matrix. So the definition also you have to study. Let A be a non-singular. Last class I explained what is singular and all, right? Remembering what is singular? A square matrix A is said to be singular if determinant A equal to 0, right? If determinant A not equal to 0, it is called non-singular. Okay, so here A is a non-singular square matrix. Let A be a non-singular square matrix. Okay, so every word is important. Non-singular, it must be a square matrix. Then the inverse of A, we denote it as A inverse. You read it as what? A inverse. The formula 1 by determinant A into adjoint A. So nothing new to learn, right? Suppose if A is a matrix, A is a square matrix. For example, it's a 2 by 2 or 3 by 3. Say we take it as a 2 by 2 matrix. So you have to find determinant A. You know how to find a determinant A. You convert it as a determinant, then expand, you'll get a number. Then adjoint A, if it is 2 by 2, you have an easy method, right? What do you do? The principal diagonal elements you interchange, other two elements you change the sign, right? But 3 by 3 means no other way. Lot of work you have to do. Then 1 by that determinant A into adjoint A. Okay, now please listen here. The first line you read, let A be a non-singular square matrix. I said every word is important, right? Two things here. One is square matrix. It must be a square matrix. Only for square matrix you can check for what? Determinant A you can find, then only you can find what? Inverse. So because in the formula we have determinant A. So one of the major difference between matrix and determinant is matrix can be of any order, but determinant must be a square, right? So in the formula A inverse, you need determinant A. So suppose a matrix is given, you have to convert it as a determinant. Only square matrix can be converted as a determinant, right? So if the matrix is not a square matrix, you cannot find inverse. Then every square matrix may not have inverse. For that there is another condition. Non-singular. First it must be a square matrix. The reason then only you can find determinant. Then it must be non-singular. Non-singular means determinant A not equal to 0. Why you know? If determinant A equals 0, what happens? See the formula 1 by determinant A. 1 by determinant A. If determinant A is 0, 1 by 0. Something by 0 not defined, right? So inverse does not exist. So inverse exists only for non-singular square matrices. Okay, it must be a non-singular square matrix. Okay, so if determinant A equals 0, you say it is a singular matrix, so inverse does not exist. Okay, sometimes they'll give a determinant, they give a matrix, with some unknown. They'll ask you to find k value, you find k, condition is inverse does not exist. Inverse does not exist means what you can say? Inverse does not exist, determinant A equal to 0. The matrix must be a singular matrix. Okay, then the inverse does not exist. Apply that condition, then you can find what? K value. Okay, hope you understood. Inverse exists means you say determinant A not equal to 0, so that you will get K not equal to some answer. So like that also they can frame questions. Okay. So hope you understood this. Some of the properties. So A's inverse, we denote it as what? A inverse. A matrix, you multiply by the inverse. Your answer will be the identity matrix. Okay, A into A inverse, or you can reverse it. A inverse into A, your answer is I. You know in numbers 5, what is the multiplicative inverse? 1 by 5, right? 5 into 1 by 5 or 1 by 5 into 5. Then what is your answer? 5 cancel, your answer is 1. Instead of 1 here, what do you have? I, identity matrix. And some other properties just to go through. If B is the inverse of A, B is the inverse of A, then A is the inverse of B. Suppose when you find AB, your answer is I. When you find BA, there also your answer is I. In 10th standard you would have studied. Then what can you say? A and B are inverses to each other. So here also, even in 11th standard, you have a question like that. They give two matrices, A and B. Prove that they are inverses to each other. What do you do? No need to find the inverse and all. Just you multiply them. You find A into B. And you find what? B into A. If your answer is I, then you can say they are inverses to each other. Okay. So here, if A's inverse is B, then B's inverse is A. A into A inverse is I already said. The inverse of a matrix is unique. In some cases, inverse may not exist. If it exists, only one inverse. That means for every non-singular square matrix, only one inverse will be there. Order of A and order of A inverse will be same. Suppose order of A is 3 by 3, order of A inverse is also 3 by 3 only. Okay. The inverse of identity matrix is I itself. So inverse of multiplicative inverse of 1 is what? 1 by 1. It is 1 only, right? So same way, the inverse of identity is what? Identity matrix only. AB inverse, in transpose you study, right? Reversal law. AB transpose is B transpose into A transpose. So same way here, AB inverse is B inverse into A inverse. Last class in adjoint I taught, right? Adjoint of AB, you write adjoint of B into adjoint of A. Order cannot be changed because matrix multiplication is not commutative. Then determinant of A inverse is 1 by determinant A. Let A be a non-singular matrix, then A square equal to I, then A's inverse is A itself. A square equal to I. Listen, A square equal to I, the meaning A into A is equal to I. A square can be written as A into A. Both the sides you multiply by A inverse. We have A into A equal to I. You multiply by A inverse on both sides. What is this A inverse into A? I. So I into A equal to, what is A inverse into I? I is like 1, right? A inverse and I is A inverse. What is I into A? It is A. So A equal to A inverse. That's a simple proof of this, okay? A square equal to I, then A and A inverse are same. Okay, sometimes the question they will ask, we have questions of this type also. So a matrix is given. The question is prove that its inverse is A itself. Prove that the inverse of A is A itself. Actual method is you have to find A inverse. 1 by determinant A into adjoint A, cofactor everything. But the easy method, if you know all these results, you can do very easily. So just you prove A square is I. A square you find out. A square means what? A into A. So multiply the matrix 2 times. Very simple. Instead of finding all the cofactors and all, right? So you find A into A. If your answer is 1 0 0 0 1 0 0 0 1. So A square equal to I, right? A square equal to I. If A square equal to I, then you can say A inverse equal to A. If you want, you can write this proof also. Okay, it is not a tough thing. Very simple only. So hope you understood that. Okay, that's all the theory part in inverse. Okay, now let us do few sums. So this is one of the example sum. A is a 2 by 2 matrix, 2 3 1 2. 2 3 1 2. A is a matrix 2 3 1 2. Satisfies the equation. See, one equation given, A square minus KA plus I. Here it is 2 by 2, so I2 equal to 0. They asked to find K value first. Find K. Also they asked to find A inverse. So okay, that's what we studied today. And this already you know, but anyhow, we'll do that. Little bit different question. That's the reason I thought of taking this. So you find A square first. A square means you square all the elements, right? No. A square means you be very careful. Don't square all the elements. A square means A into A. So A square is A into A. So write it 2 times. 2 3 1 2 into again 2 3 1 2. Row by column, right? First row, first column. 2 into 2. 4 plus 3 into 1 3. First row, second column. 2 into 3. 6 plus 3 into 2 6. Second row, first column, 1 into 2, 2 plus 2 into 1, 2. Second row, second column, 1 into 3, 3 plus 2 into 2, 4. So what you are getting here? 4 plus 3, 7, 12, 4, 7, right? This is a square. And what is given in the question? It is given in the question a square minus ka plus I equal to 0. 0 means 0 matrix. A square, you got it. 7, 12, 4, 7 minus k into a. What is a? 2, 3, 1, 2 plus I2. I2 is the identity matrix of order 2. 1, 0, 0, 1. Equal to 0. 0 means 0, 0, 0, 0, right? Okay, even one part is enough. If you want, you simplify fully. Otherwise, you take only the first element alone. But you want to do fully, right? Okay, listen. First element alone means how you to take, Here what is that? 7. Then minus k into 2. So minus 2k plus 1, right? Plus 1 equal to, in the answer also you take the first number. I am taking only the first numbers. So what do you get? 7 plus 1, 8 equal to minus 2k, take that side plus 2k. So you are getting k equal to 8 by 2, 4. That's all. But if you want to simplify, you can write, nothing wrong. Even you can do like this, just to say implies. Either take, because only k they asked, right? So it is not compulsory to do fully. If you want to do, you can do that. See what you do, 7, 12, 4, 7, you write as it is, minus, by that k you multiply everything, what you get? 2k, 3k, 1k, 2k, plus what? 1, 0, 0, 1 equal to 0, 0, 0, 0. Now please listen. So for this and this you can add it, right? So 7 plus 1, 8, and this one minus 2k, 8 minus 2k. Next one, 12 plus 0, that is 12 only. Here minus 3k, right? Minus 3k. Next one, 4 plus 0, 4 only, 4 minus k. 7 plus 1, like terms, first and last, 7 plus 1, 8 minus 2k, equal to the answer 0, 0, 0, 0. Two matrices are equal, so the corresponding elements are equal. First equal first means, okay, you'll get, already I taught that, okay. Or second equal second, you will get the same answer. Third equal to third, that's the most simpler one, right? 4 minus k equal to 0, or 4 equal to plus k. So anyhow, k value 4, any one method you do that, okay. So the first part is over. Next, what they asked, also find A inverse. That only today's class, right? We want to find A inverse, but it is a 2 by 2 matrix only. So we start with A. What is A? 2, 3, 1, 2. A equal to 2, 3, 1, 2. Please listen here. We want A inverse, right? So you write the formula first, then only you know you can understand what are things you need, right? So A inverse equal to 1 by determinant A into adjoint A. So take it as equation number 1. We need two things. What are things you have to find? You have to find determinant A. Another thing you have to find what? Adjoint A. Which one you do first? You find adjoint A or determinant A? Some of you may think we'll do adjoint A first, right? Because easy only, 2 by 2 matrix, just to interchange. Then you find determinant A anyhow. But I am advising you, better you go for determinant A first. Why, determinant A you find, suppose your answer is 0. What you can say? It is singular, inverse does not exist. But since it is 2 by 2 is okay. So even you find adjoint, it won't take much time. Otherwise, suppose you imagine a 3 by 3 matrix, suppose a 3 by 3 matrix is given. You want to find inverse. You are finding adjoint first. Adjoint means you have to start with what? Cofactor. You are finding all the cofactor, 1, 1, 1, 2, 1, 3, plus, minus, leave the row column, you write everything. Then cofactor matrix, adjoint. Okay, then you are finding determinant A. Suppose determinant A is 0. What will happen, right? So what you did, everything is mere waste, right? We say it is, so better always you find what? Determinant A first, okay? So that's order you have to follow. So find determinant A. So write it as a determinant 2, 3, 1, 2. Determinant symbol you have to change it, okay? So don't expand the matrix. 2 2s are 4, minus 1 into 3, 3. So the answer is what? 1. So this is determinant A. Adjoint A, just two changes, right? Principal diagonal 2, 2, interchange. Since both are same, there is no change. It is 2, 2 only. Other two elements, you change the sign. 3 become minus 3 and 1 become minus 1. This is adjoint A, right? We want A inverse. So substitute in the first equation. A inverse equal to 1 by determinant A is 1 into adjoint A is 2 minus 3 minus 1, 2. So 1 by 1 is 1 only, leave it. So 2 minus 3 minus 1, 2 is your answer here. So shall we go for the next question? It's a very simple question, you can do that. Now in the exercise, so I'm taking few important questions. So in every question, you have to find the cofactor, because inverse you need, you have to find the cofactor, then only you can go for adjoint, right? Look at this question. A equal to 133, 143, 134. Verify A into adjoint A equal to determinant A into I. Also find A inverse. So to find A inverse, anyhow we need determinant A and adjoint A, and here one multiplication also you have to do. Okay, they'll ask this as a 5-mark question. So first you find determinant A. Okay, so find determinant A. So it's a revision for you. Okay, so determinant 133, 143, 134. So expand it. Take the first number. What's the first number? 1 into. Leave the row and column. 4 4s are 16, minus 3 3s are 9. Take the second number. When you take the second number, you have to change the sign. Minus 3 into. Leave the row, leave the column. 1 into 4, 4, minus 1 into 3, 3. Then plus 3 into. Leave the row and column. 1 into 3, 3, minus 1 into 4, 4. So simplify. 1 into 16 minus 9, 7, minus 3 into 4 minus 3, 1, plus 3 into 3 minus 4, minus 1. 1 into 7, 7, minus 3, minus 3. So 7 minus 6, you are getting 1 here. Determinant A is equal to 1. So 1 by determinant A, 1 by 1 only, so that become 1, right? So determinant A got it. So determinant A into I, that you will get 1 0 0 1 only, right? Now A into adjoint A. So for that you have to find all the cofactors, right? You have to find the cofactors. So you know how to find cofactors. So we take like this, right? A11, A12, A13, A21, A22, A23, A31, A32, A33. For cofactor, either you put A or you can use what? C, right? So then cofactor means it is what? Signed minor, right? So you have to look into the sign also, but already we studied. For 3 by 3, you know it is plus minus plus minus. How? Already I explained the previous videos. So you put plus minus plus minus plus minus plus minus plus, right? So this one sum I'll teach fully. Okay, so next sum onwards I'll tell you, you find adjoint. Okay, I'll teach only the other things. I'll tell you the method how to do it, because I don't want to waste time. Okay, so we'll write the matrix one more time here. 1 3 3 1 4 3. 1 3 3 1 4 3 1 3 4, right? Okay, look here. So A11. So take the first number, leave that row, leave that column. 4 4s are 16 minus 9. 16 minus 9. We'll simplify later. Second number 1 2. Second number, leave that row, that column. 1 into 4, 4 minus 3. 1 3. Third number, leave that row, that column. 1 into 3, 3 minus 4. 2 1. Second row. That 1 is there, no? Leave that row, that column. 3 4s are 12 minus 9. 2 2, the middle number 4. Leave that row, that column. 1 into 4, 4 minus 1 into 3, 4 minus 3. Now 2 3, that 3 is there, no? So that number. Leave the row, leave the column. 1 into 3, 3 minus 3. Now you come to the next row, 3 1. That 1 is there, right? Leave the row, leave the column. 3 3s are 9 minus 12. 3 2, that is this 3. Leave the row, leave the column. 3 minus 3. And the last one, 3, 3. So leave that row, leave that column. 1 into 4, 4 minus 1 into 3, 3. 4 minus 3. So you have to simplify all these, right? So 9 minus 7, what you're getting, it is what? 7. 4 minus 3 is 1, but outside minus, so it is minus 1. Next one is also minus 1. Next one is minus 3, then 1. Next one 0, then minus 3, again 0, 1, right? Okay, we got all the cofactors. Now we write cofactor matrix. What is that? Aij, that is the cofactor matrix. So the replace elements by the corresponding cofactors. First 3 cofactors, write it as first row, 7 minus 1 minus 1. Second one, minus 3, 1, 0, minus 3, 1, 0. Last 3, minus 3, 0, 1, right? Minus 3, 0, 1. This is cofactor matrix, but we want adjoint A, right? So adjoint A is transpose of Aij, right? Cofactor matrix transpose. So first row, you write it as first column. First row, 7, minus 1, minus 1. Second row, minus 3, 1, 0. Third row, minus 3, 0, 1. So this is adjoint A. Okay, so already we studied this. Now please listen here. What you have to find adjoint A got it. This is a major work. Okay, so once you know this, now we have to find A into adjoint A. We find A into adjoint A equal to determinant A into I. So among these two, LHS or RHS, which is easy to find. A into adjoint A, or A is a 3 by 3 matrix, adjoint another 3 by 3 matrix, row by column at the right, you will get 9 entries. So you have to do a lot of work there. But determinant A and I is very easy, right? So what I'm going to do, we have to find A into adjoint A, right? A into adjoint A. So A, already we written that, right? 133, 143, 133, 143, and 134, right? Yes, 134. So this is A into adjoint A. Adjoint A, got it now. 7 minus 3 minus 3, minus 1, 1, 0, minus 1, 0, 1. Now we have to multiply these two. So before multiplying this, what I'm going to do now? So I'm finding the right side. What's the right side? Determinant A and I. So because you are supposed to get that answer, right? So determinant A and I. What is determinant A? Got 1. In the I is 1, 0, 0, 0, 1, 0, 0, 0, 1. Why you are not writing 1, 0, 0, 1? Here A is a 3 by 3 matrix. So you have to write I3, right? So now outside number is 1. So by that 1 you multiply everything. So no change. 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. Suppose determinant A value is 7. 7 into I3. So you multiply every term by 7, then you would have got 7, 0, 0, 0, 7, 0, 0, 0, 7. Okay. Why I am writing this, if you multiply these two matrices, you are supposed to get that, right? So you can understand whether it is correct or not. If not, you have to check it. Okay, so do it very carefully. So matrix multiplication, row by column, right? First row, first column, 1 into 7, 7, 3 into minus 1, minus 3, 3 into minus 1, minus 3. Now itself you check. Minus 3 is minus 6. So 7 minus 6, 1. Yes, you got it. Now first row, second column. First row, second column. 1 into minus 3, minus 3. 3 into 1, 3. 3 into 0, it is 0. Yes, minus 3 plus 3. What answer? 0, right? Okay. First row, third column. 1 into minus 3, minus 3. 3 into 0, 0. 3 into 1, 3, right? So again you are getting 0 only. Second row, first column, 1 into 7, 7, 4 into minus 1, minus 4, 3 into minus 1, minus 3, right? Then second row, second column, 1 into minus 3, minus 3, 4 into 1, 4, 3 into 0, 0. Second row, third column, 1 into minus 3, minus 3, 4 into 0, 0, plus 3 into 1, 3. Now come to the last row, third row, first column, 1 into 7, 7, 3 into minus 1, minus 3, 4 into minus 1, minus 4. Third row, second column, 1 into minus 3, minus 3, 3 into 1, 3, 4 into 0, 0. Last one, third row, third column, 1 into minus 3, minus 3, 3 into 0, it is 0. 4 into 1, 4. So if you simplify this, you will get 1 0 0 0 1 0 0 0 1. You will get this, okay? If you're not getting, right, everything 1 0 0 0 1 0 0, suppose instead of this 0, if you get some other answer minus 3 or minus 7, right? Then you will start sweating and all, right? In the exam hall, you find very difficult. So while finding cofactor, you do very carefully. See, if you are not getting, because you know this is prove that sum, so you are supposed to get that, right? Then you will check everything. Where you check, you start from cofactor, everything, right? So once the time goes, you will find very difficult, okay? So while doing itself, do very carefully, and you need more practice. Matrix is very easy only, but at the same time, don't take it light. Other areas, you won't write much when you go for some other topics. So you may find little difficult to learn, but you can save time. It won't take much time, but matrix is like one. In my later videos, I'll tell you, when you go for the public examination, okay, you learn everything and go, but there is some choice. So which one to leave in choice? This is one such sum. But I'm not telling don't study, you learn everything. But for the annual examination, when I give the exam tips, I'll tell you what to do and what not to do, okay? Right. So is it over? Not yet, right? So only this part is over. Now you have to find what? A inverse, but everything is already there, just you have to copy it. So they asked to find A inverse, right? So write the formula. So they asked to find A inverse. What's the formula? 1 by determinant A into adjoint A. So that is 1 by determinant A. Determinant A is what? 1 only into adjoint A. So what is adjoint A? This is adjoint A, right? Okay. 1 by determinant A into adjoint A. But you cannot copy and paste like this, okay? So 1 by 1 is 1 only. So what's your final answer? 7 minus 3 minus 3 minus 1 1 0 minus 1 0 1. Okay. So even though we have taken some time, but this is actually a revision for what you studied in the previous videos and all, right? Those who missed also, I think you would have understood now how to find cofactor, how to find adjoint, how to find inverse. Even for the next exercise fully, we want inverse, okay? So in that video, I won't take all these things. Straight away, I'll write inverse and I'll teach the sum, okay? So hope you understood this. Now let us go for the other sums little quickly. Find the inverse. I think I no need to do that, right? Find the inverse of the matrix. What's the method alone? I'll tell you, you can practice it. So you give a name to the matrix, okay? You take the matrix as A, then immediately write the formula. A inverse equal to what's the formula? 1 by determinant A into adjoint A. Take it as equation number 1. Then you find determinant A. Don't simply expand it. You convert it as a determinant. The symbol you change. Okay. So write the matrix, expand it very clearly. So very carefully. You get some answer. Don't forget to put not equal to 0. So once you get determinant A, whenever you go for inverse, that is your condition, right? Determinant A not equal to 0. So you show that. Suppose if your answer is 0, you check it once again. Suppose by mistake you would have done some mistake, you would have got 0. You check it. But when it's a 5-mark question, they won't give such questions. Okay, anyhow, if there is some printing mistake or not, you check it very carefully. Okay, if it is 0, you check one more time. Yes, you are sure it is 0. Then you say it is singular inverse does not exist. Okay. So make sure it is not equal to 0, so inverse exists. Then you go for what? Cofactors, form a cofactor matrix, adjoint, then A inverse equal to 1 by determinant A into adjoint A. Next question you see. So A, B given, verify this result. So you know how to do that. Just I'm going to tell you what are the steps you have to do. A, B, two matrices given, right? So first you have to find what? A into B. We have to find the term inside the bracket. So you find A, B first. So multiply the two matrices 2, 3, 1, minus 6 into minus 1, 4, 1, minus 2. Row by column. Do very carefully. Sometimes carelessly, what do? You multiply term by term. So don't do that very carefully. Row by column. 2 into minus 1, minus 2, 3 into 1, 3. First row, second column, 2 into 4, 8, 3 into minus 2, minus 6, right? Now come to the second row, first column, 1 into minus 1, minus 1, minus 6. Second row, second column, 1 into 4, 4 minus minus plus 6 2s are 12. So what answer you are getting? You are getting here 1, 2, minus 7, 16, right? This is AB. Then left side is what? Adjoint AB. Adjoint AB means just two changes, right? Principal diagonal interchange. 1, 16, you write 16, 1. Other two elements, you change the sign. 2 become minus 2 and minus 7 become plus 7. That is equation number 1. This is the answer for what? LHS. RHS you can complete it. So first you find adjoint B. All of you know how to write adjoint B, right? Two changes. Principal diagonal interchange. Other two elements you change the sign. So minus 4, minus 1. Then adjoint A. Here you find the adjoint. Okay. Then multiply adjoint B first. Adjoint B into adjoint A. Matrix multiplication. That answer 2. Check whether both the answers are same. Look at the next question. A is given. Show that adjoint A into A equal to 0. A is given. You find adjoint A. Find all the cofactors. You need practice. Okay. Find all the cofactors. Cofactor matrix transpose. That is adjoint A. Then adjoint A into A. In some other question we proved A into adjoint A equal to adjoint A into A equal to determinant A into I. Right. But in this question they asked to prove it is what? 0. So you multiply 0 means what? 0 matrix. All the elements are 0. You will get a 3 by 3 0 matrix. Okay, that you can check it. See the next question. A is a matrix given. Show that the inverse of A is A itself. Show that the inverse of A inverse is A. Two methods. Already while teaching the theory part I explained. One method, you find A inverse in the usual method. So find determinant A, adjoint everything. 1 by determinant adjoint A. Your that answer and A both must be what? Same. Another easy method is there. What is that? A square equal to A. Sorry, A square equal to I. So the theory, that is more important. Okay, once you understood all the results, concepts, then any sum you can do it. So A square you find out, right? A square. How can you find A square? A into A. Write that matrix 2 times. Check whether you are getting the identity matrix I. So you are getting A square equal to I. That is self enough. Once A square is I, you can say A inverse equal to A. How you are getting? If you want, you write the proof also. Because very short you can do that, right? Only 2 matrices you multiply, no cofactor, nothing. That's the easy method. If they specify, find the inverse of this matrix and prove, then no other way, you have to find A inverse. If it is not mentioned, you can go for this method and this is the easiest method, right? So after getting A square equal to I, how to get this answer? I already explained. Just to go through one more time. A square is what? A into A equal to I. Both the sides we multiply by A inverse. Okay. So A into A equal to I. So what I'm going to do, I'm pre-multiply by A inverse. So A inverse and I is A inverse only. Here you group these two. A inverse into A, that is I into A. I into A is what? A only. So A equal to A inverse. Once you proved A square equal to I, then you can say A and A inverse both are what? Same. Look at the next question. A inverse is given. Listen, you know this property. A inverse, the whole inverse equal to what? A. A inverse is given. This is A inverse. What they asked to find? A. So A equal to A inverse, the whole inverse. For you, if you want to do very simply, let A inverse equal to B. I am taking A inverse as what? B. But we know we want to find A. A equal to A inverse, the whole inverse. A equal to A inverse, the whole inverse. A inverse only I named as what? B. So you find B inverse. So A is equal to B inverse. What is B? This is our B. This only I have taken as B. Otherwise you will be confused. Determine A inverse, right? So A inverse, the whole inverse. So the final step you can change it. Okay, so you take that as B. What is B here? The A inverse, what they given, that is our B. Then B inverse. What is the formula for B inverse? B inverse is 1 by determinant A into, determinant B into, right? Because B is there, no? Determinant B into adjoint B. Usual method you can do that. So then finally you can say B inverse you find out, right? You are finding B inverse. What answer you are supposed to get is what? The same answer, 103. Find A. Whatever answer you get, you write it. And instead of B, now you can write B can be replaced by what? A inverse. B can be replaced by A inverse the whole inverse is that answer. A inverse, the whole inverse means what? A. So A is given, you know how to find A inverse. If A inverse is given, how can you find A? You take inverse one more time. So you take the inverse of A inverse, okay? So hope you understood all these things, and you go through the other sums. If you have any doubt, I'll help you in the next class. So practice cofactor, then you can answer any question. We'll continue in the next class.